Welcome to the second to last video of Chapter 6. This video is going to cover what are called the remainder and factor theorems. So let's just jump right in. We're going to talk about synthetic substitution. To find f of r for some number r, you're going to use synthetic division to divide by r. The remainder is f of r. Okay, so let's look at example number 1. We need to find f of 4. So let's review. What does that mean? It means we're plugging in a 4 for x. So let's try that the way we've normally done that. So before, we've plugged in a 4 for x. And this worked well for us, except when we're not allowed a calculator. If I'm not allowed a calculator, do I know what 4 to the 4th is? Well, it's 256. 4 to the 3rd is 64. These numbers get big quickly. So this is not convenient. It works, but the numbers are too big. So it works, it's just not convenient. What I can do instead is I can divide by 4 using synthetic division. So bring those coefficients out. Notice, though, we do not have an x squared, so we're going to need a 0. We have 3x to the 4th, negative 2x cubed, 0x squared, 5x, and 2. As a review, the first number comes down, then we multiply. So 4 times 3 is 12. Remember, you're always adding, so we get 10. 4 times 10 is 40, add down. 4 times 40 is 160, so I get 165. And then I need to do 165 times 4. Okay, that one's a little bit bigger than I want. That's okay. I end up getting 660, and we get 662. Your answer is the remainder. So we would say f of 4 is 662. Did we still have big numbers? Yes. Still have big numbers, but definitely easier than what we did initially. I will tell you, if you had finished this, or if we had finished it, put it into our calculator, we would still get 662. Okay, let's do example number 2 together, please. We are finding g of negative 1. Again, that means that x is equal to negative 1. We could plug negative 1 into the equation and find it that way. But I want us to review or to try again this synthetic substitution. So we're going to be dividing by negative 1. Remember, your terms have to go in order, which ours do. We're not missing any terms. So I'm ready to bring down those constants. First number you bring down, then you're ready to multiply. So negative 1 times 2 is negative 2. Add down. Add down. Negative 1 times 9 is negative 9. Adding, of course, we get negative 121. So we can see g of negative 1 is negative 121. Again, if we had plugged in negative 1 into the equation, we would have gotten negative 121 again. That's true. But we can see here, our numbers were a lot more convenient than if we had tried to use the equation. On a checkpoint or on a learning check, I'm specifically going to say you need to use synthetic substitution. So make sure you are using the method that I am asking you to. Okay, so that was actually called the remainder theorem. So that was the first theorem we needed to talk about. Second theorem is what's called the factor theorem, which is also going to involve synthetic division. So it says the binomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. Okay, here's what that practically means. Looking at example 3, we need to determine is x minus 3 a factor of what is given. We need to figure out is p of r equal to 0. How are we going to do that? With synthetic division. So we are going to divide our polynomial by this polynomial to see if we have a factor. Instead of -3, +3 goes in the box. Again, make sure your terms are in order, which they are. We have x cubed, x squared, x, and our constant. Are we missing anything? No. So we're ready to bring out those constants. Remember, first number comes down, then we're ready to multiply. So 3 times 1 is 3. Then add, so we get 7, 21. Add, we get 18. Add down. This number is our remainder. I will tell you, if the remainder equals 0, then we say, yes, this is a factor. So, in our case, remainder equals 0. What does that tell us? It tells us x minus 3 is a factor. Now, we're not finished yet. We have to find the remaining factors. So as a review, looking at these numbers here, the 1, 7, and 6, if this is an x cubed, our quotient when we divide will always be 1 less. So what we have is x squared plus 7x plus 6. We need to factor this. So 3 terms split in the middle. Looking for 2 numbers that multiply to 6 and add to 7. Multiply to 6 and add to 7 is 6 and 1. So I'm going to get x plus 6, x plus 1. And those are my remaining factors. This is not an equation, so we are not solving. Don't set them equal to 0. We're just factoring. Okay, next page, you all have an example to try. It's this one at the top. Determine whether x plus 2 is a factor of that given polynomial. Then find the remaining factors. I'm going to start you out and then let you finish the problem. If we want to know if x plus 2 is a factor, in the box, we're dividing by the opposite, so by -2. Then, are these in order? They are. Are we missing any terms? No, we're not. So bring down the constants, 3, -4, -17, and 6. The rest of this problem is up to you, so you need to finish this problem and turn your notes in. If you're unsure what to do, it might be helpful to look at the next example with me, which is an extra example. The required part of the video is over. If you would like to stay on with me to go over example 5, please do so. Okay, extra 2 examples. Example 5, determine whether x minus 1 is a factor, then find the remaining factors. So 1 goes in the box. As before, we're switching signs. If we look at our polynomial, we should notice we're missing an x squared. So we're going to need to put in a 0 as a placeholder. Bringing our constants, we have 2x cubed, 0x squared, -10x, and 8. So we bring down our 2, multiply, add down, multiply, add down, multiply. Okay, remainder of 0 tells us, yes, we have a factor. What does that mean? It means x minus 1 is a factor. Those 3 dots are just our conclusion. So that's a symbol in math. 3 dots, you're writing your conclusion. Okay, if we started with x cubed, our quotient, or what remains when we divide, is 1 term less, or 1 exponent less. So knowing that, we end up with 2x squared plus 2x subtract 8. We're factoring this, so we notice we have a GCF of 2. Take out that 2 and we get x squared, add x minus 4. Okay, now we're factoring some more. 2 numbers that multiply to 4, -4 rather, and add to 1. There aren't any. So this is our last factor. And one last example, which is example number 6. Same type of idea we've been doing before. Is this a factor, yes or no? Find the remaining factors. If you want to try this one on your own, please feel free to pause this one and then come back when you are ready. Okay, x plus 3, so we're going to put in -3 in the box. So then we have 1, -1, -8, and 12. Again, bring the first number down. Then you're ready to start multiplying. So -3 times 1 is -3. Multiply, this gives me 12 and 4. Multiply, and then I get a 0. That tells me that I do have a factor. So again, a remainder of 0 tells me I do have a factor. So then I have x squared minus 4x add 4. Looking to factor this. Two numbers that multiply to 4 and add to -4. They don't exist. That means this does not factor anymore. So if we were to factor this polynomial, we would get x plus 3, and then x squared minus 4x plus 4. Okay, so this idea of the factoring is going to help us when we move on to the next section of solving. Thank you for watching a few extra examples. Hopefully they helped you. If you have any questions, write them down, come to office hours, or please feel free to ask in class.